All right, we're going to go over now. I'll just do a really quick intro so that we've still got plenty of time for Graham's presentation and some more questions. Graham Page is the business development lead at Terrigen, an Australian ag biological company focused on improving livestock and plant performance through microbial science. This is a really exciting area of work that Farmers for Climate Action is really looking into as well. Graham has nearly 3 decades of experience in agronomy, technical leadership, product commercialisation, and industry extension. He has a strong professional interest in improving input efficiency, system resilience, and long-term farm profitability. So, obviously with a focus on microbial technologies. So I'll hand over to you, Graham. Thank you.
Thanks, Helen, and thanks everyone for joining us this afternoon. And thank you, Harry. It was great insight to urea application and how we can get better efficiency out of urea. My presentation specifically around biostimulants and live microbial biostimulants, which is a main driver of what Terrigen does, whether it's dealing with probiotics in livestock or dealing with biostimulants in plant and crop production. If I could go to the next slide, please. Yeah, so I think it's been covered, but let's just to sort of set a base. Like if we think about the current challenges around what's dealing in agriculture today around productivity and whether that through supply or just in general around declining soil health, it's really important that we have key messages out there. We're driving the focus around soil health and productivity and the environmental pressures that are coming down on everyone, and obviously the exact fertilizer costs and tight margins. But we do need to get better at how we can improve the soil ecosystem and improve the biological activity within that. Some of that I'm going to share with you guys today on some of the work that we're doing. And obviously some of the systems that we've approached here in agriculture are actually changing the dynamics of the soil. So how can we better enhance that? How can we get more out of our soils and how can we help our plants do that without relying heavily on synthetic fertilizers? I agree with Harry. We can't necessarily take them out immediately. There is opportunities in certain climates where we can actually move towards a lot less synthetic fertilizers, and we've certainly got plenty of examples across Australia of producers doing that. But it's not a start and stop scenario. It is something we would need to work through as an industry. Next slide, please. So I will focus on Greatland Plus, which is a product of Terrigen, but really the message is around live microbial products. There's a lot of products here on the market that fit within the biostimulant category. I think it is an area that we do need education on. Not everyone really understands the difference between the different biostimulants and the products that are out there, and there's certainly a number of products that are on the market today. If I could go to the next slide. So what is a biostimulant? So Fertiliser Australia, I don't know if people are aware, have recently put together a code of practice around biostimulant products, and they're actually bringing in some governance and control around what a biostimulant is. So I will just read this out just to be clear. So a plant biostimulant is a substance or substances, microorganisms or mixtures thereof that when applied to seeds, fertilizer, plants, or in the rhizosphere soil or other growth media, act to support a plant's nutrition process, independently of that biostimulant or product's nutrient content. So it's really critical to understand that a biostimulant is not a fertilizer. And thereby, biostimulants improve one or more of many things, including nutrient availability, uptake, and use efficiency, which is absolutely critical. Tolerance to abiotic stresses such as drought, salinity, and disease, and consequent growth, development, plant vigor, crop quality, and yields. And I'll go through some demonstrations that we've been working on over the last 6 to 12 months that can share some of those insights on how we're achieving that today. So Greatland Plus is designed to unlock and cycle nutrients that are already in the soil while improving the root development and nutrient uptake. So what is Greatland? It's a live microbial product that has 4 lactobacillus in it. It has acetobacter, so acetic acid producing bacteria. It also has a yeast in it, and it's mixed with potassium humate, and it has molasses as a food source. It's quite compatible with a lot of other products. So one of the challenges we have with people adopting biostimulant products into their program is, do they have to put on a separate application? No, not always. You can actually fit it within the existing programs and the existing systems. And it has fitted in quite well within broadacre and pasture programs. Next slide, please. So how does it work? It's very simple. A biostimulant like a live microbial product will directly work on the plant and in the soil. So you will see a direct stimulation of the plant through auxins and plant auxins that the microbes themselves can help generate and stimulate the plant to grow. You will see a significant difference under the ground within the rhizosphere. So you generally see root establishment and biomass, which once you start building up those networks, you also see how those root exudates are working and the plants actively working with the microbes and the fungi in the soil. And then that then helps that plant attract and obviously retain more nutrients into the plant. And by doing that and by applying microbes into the soil like Greatland Plus, you're actually helping that plant build a beneficial community. So you're actually building up that community over time, which you get better cycling of nutrients, you get better carbon, soil organic carbon, and as we all are fully aware of and comfortable with, as we start to build up that soil ecosystem, we start to get better nutrient pathways, we get healthier soils, and we get healthier cropping systems, which then help become less reliant on these synthetic fertilizer products like urea and DAP and MAP. So basically, we need to stop treating our soil like dirt. We need to be a bit kinder to it. Next slide, please. So thinking about how does this work practically in the field, over the last 12 months, I've been actively working with some key producers across Australia to look at how we can best apply Greatland into their existing system and how do we measure that performance at a large scale. So instead of doing small plot replicated trial work, which would tend to be 10 metres long by 2 metres wide, you might replicate that 6 to 7 times depending on what you're trialling. We're using software out there like a program called Laconic, which can measure trial performance in a replicated manner over a large system. So this particular trial that I'm talking about here at Ravensworth was in maize silage trial. We had 4 different treatments and we replicated that 13 times. So to put the scale into perspective, each one of those replicates was 60 metres long by 46 metres wide. So we're talking large scale replicated trial. And we get some statistical and measurable data out of that. Next slide, please. So the results from this trial, we did take soil biology tests. I haven't got those results on me here, but if anyone's interested in them, I will share you. They're very, very comprehensive. But what we did manage to achieve here, and this is a very heavy system in far as they put on 411 kilos of nitrogen onto their cropping system. They were growing maize silage, wet tonnage they were averaging around 75 tonnes to the hectare. They were looking to increase that productivity to over 80 tonnes per hectare. But they realised that even though they use organic amendments like manure, compost at 20 tonnes to the hectare, they weren't getting any benefit by putting on more fertiliser. In fact, they were actually only adding to some of the systems and the challenges within their soil ecosystem. So we incorporated live microbial products like Greatland into their program. And what you can see on the right there, when we did a late stage leaf analysis, we were seeing higher nutrient efficiency and uptake into the plant versus the control, which was their standard practice. And that converted through to yield. So the green line there at the top. So we actually managed in this particular trial across 5 of those 13 replicates, we actually achieved over 90 tonnes. So that was a 12.2% average increase over their standard practice in yield and $1,100 return on investment, which was a great result and something that they're now going to incorporate across their whole farming program. So they weren't reducing their program at this point in time, but certainly in time, they now see the value in how they can actually reduce their synthetic fertiliser import and work better with their soil biology and their soil ecosystem. Next slide, please. In addition to that, we've recently, and this trial isn't completed, so I need to state that it's still ongoing. We're at the final stages now, but we incorporated living microbes into 3 major crops in WA, Waroona, WA. This is in collaboration with Nutrien, Melody ID, Dr. Sophie DeMeyer. People may come across Sophie's working very hard at building some mechanisms around how we can better measure the soil biology and how we make better decisions around how we can manipulate the balance between bacteria and fungi and work with our soil ecosystem. So this particular trial was across sorghum, maize, and perennial ryegrass pastures. Next slide, please. As you can see, it's a little bit difficult to see the graph there, so I'll just walk through it very quickly. So the orange bars are pasture, so that's the ryegrass pasture. The yellow bars are the sorghum, and the green bars are the ryegrass trials, the maize trials. Sorry, I'll get that right. So just repeat that. You've got the ryegrass in the orange, the sorghum in the yellow, and the maize in the green. And what we're able to do is by implementing live microbial bacteria into this farming system across these three different crops, we have been able to increase their yield. As you can see down the bottom, in some of the nutrient analysis that have been taken, we are seeing increases in nitrate nitrogen levels in the plant. We're also seeing increases in some of the other macronutrients as well and micronutrients. So it's really good to see that we can demonstrate by applying living microbes into the program that we are increasing the root biomass, and we've got measurements around that. We are changing the soil ecosystem. If we go to the next slide, we'll be able to see that. So this is a very complicated graph. I've only got this information this morning, so it's red hand off the press. But in summary, what we're actually been able to prove here is by using and introducing live microbes, we've actually changed the balance in the soil of bacteria and fungi. And some of the key points out of this is in the bar graph on the far left-hand side in the control, the blue section is Fusarium, which is like a pathogenic bacteria that can actually impact the yield of the crop. And on the right, you can see that we've actually reduced the amount of Fusarium in the soil by introducing live microbes. What we've also been able to identify in these soil results is actually how we've improved the amount of bacteria or microbes in the soil that are actually helping break down organic matter and helping that nutrient cycling as well. So this is really interesting work that we're going to continue to do that's actually helping people understand more around how we can use these type of products into their farming system and help them with better nutrient use efficiency and certainly in situations where we're seeing challenges around synthetic fertilizer use or opportunities to the point on how we can reduce our synthetic fertilizer use. Next slide, please. So how would you incorporate these products? What we're seeing is a lot of people in a cropping system, they will apply it once. They'll go in early 3 to 4 leaf stage as a foliar spray. It is compatible with other products, but I highly recommend that you always get and seek advice or at least do a jar test when mixing products. But always seek advice of an agronomist. And they fit very, very well in a high value cropping system when you're looking to reduce your fertilizer or you just generally want to improve your soil health. If you're looking to change and improve your soil health. In a pasture system, we generally apply it 3 times, summer, autumn, and spring, and generally fitting within a grazing program or a hay or silage program. What you will also see in those programs, you will actually see animal health performance, and we've got some really interesting data, independent data done through Queensland University of Technology, where we actually saw reduce health issues, mastitis in cows, dairy cows, for example, while increasing their milk production by over 10%. That data is all available on the Terrigen website if anyone is at interest of looking at that trial result and the other trials. Next slide, please. So just in summary, why would we incorporate live microbial products into our system? You get better nutrient access, you're obviously getting better root performance and growth, you get better plant resilience to combat abiotic and biotic stresses and diseases, and you can lower your fertilizer dependency and overall increase your productivity. And just lastly, we'll flick through the next 2 slides quite quickly. Just an overview on Terrigen, because people may not be aware. It's an ASX listed company. It's been around since 2009. I only joined Terrigen 12 months ago. They've got a very strong leadership team. They've got significant researchers with 2 laboratories. They manufacture their own products here in Australia. So, and they've got 14 peer-reviewed papers and have a distinct methodology around how they bring their products to market. So there's high quality control and quality assurances around. So we guarantee the analysis within the products and CFU count or the live microbes in our products, whether that be a probiotic or a biostimulant. That's it. That's all from me. So a brief update, but hopefully giving you guys something to think about.
Thank you very much, Graham. That's really interesting, and yeah, it's definitely a ever evolving space. I'm so we're going to have time for some questions now, and so flick them in the Q&A would be fantastic. And also we've got some that were pre-submitted. Just quickly, Graham, since it's a live biological that you're putting on the soil, can you run me through quickly, like does it need to be kept cold, or the storage,
Yeah.
and also if it's where it's made and things like that, please?
Yeah, it is a very good question. So, yes, it's preferred that obviously microbes would prefer to be kept reasonably cool. I mean, once you get over 50 degrees, it does have a detrimental effect on the microbes. But in all honesty, a lot of our products are stored, as long as they're stored out of sunlight, which is really critical, that you're more critical than temperature, that you store them out of sunlight. From a development point of view, the fermentation, they build up the seed inoculant, which is as I said, there's Lactobacillus acidobacter candida yeast products within a product like Greatland. They build that up, they ferment that, they build up the numbers, and then they would batch manufacture that, which is here in Australia. Um, think about breweries and fermentation and creating beer, very similar in processes. And then that would be then put straight into whatever size product that people need. That can be put in drums of 20s, 200 litres or IBCs, and it can be distributed out. But it is really critical that people think about this in advance of their programs, and to when a product first comes out, its analysis is at its highest peak. There is no doubt that over time in the liquid form, it does deteriorate. So you want to order on demand, and you want to actually get a product that's actually, especially with when people are guaranteeing live counts on their label. Like in Greatland, there's 40 million live bacteria per mil guaranteed. The analysis is actually quite higher than that. So it's really critical to get that piece right. What I will say lastly is there is technology today where you can actually dry freeze the microbes, which then puts it in a more stable environment. So from a shelf life point of view, you can get up to 2 years shelf life in that formulations. So that's also available.
Thanks. All right, question for you now, Harry. What actually I've got two because one's pretty quick. What water temperature is best? I think they put that in there when you were talking about the dissolving urea and the water temp. And then in the dissolved urea comparison, where would dissolved urea applied as fertigation rather than foliar spray sit in terms of efficiency expectations?
Yes, I'll answer the water temp one first. Warmer is always better. Um, Typically, as I mentioned, with doing it in the summer period, if you can do it in summer, you're going to get a better dissolution rate of that urea versus a cold day. There's not necessarily a right or wrong temperature to do it at, but you'll find that the 400 kilos of urea going into your 1,000 liters of water will just take a longer time to do it. So if you can get a heating element on it, you don't have to get it boiling or anything to that regard. But yeah, just warm enough that you start to get it dissolved up to sort of 40 degrees, 50 degrees is even appropriate. So. On the fertigation front, it depends very much if you're fertigating onto above ground biomass or if it's onto bare soil or at what stage of the plant growth cycle it's in. Obviously, some of the biostimulants and the fulvic acid, these sort of things that we recommend putting with it is going to help to chelate, but you get maximum efficiency when it's going straight onto the plant as opposed to the soil profile. Certainly, there's benefits to the soil profile, and you'll have to put on a respectively higher rate to get the same effect because some of it's going to then have the interactions in the soil profile that I mentioned earlier with volatilization or denitrification or these sort of things. But certainly foliar application is the winner for efficiency.
Thank you very much. Now I'm just going to jump over to one of our pre-submitted questions. The person said, I was surprised last year when I attended a government agency soil health workshop, and there was lots of talk about tonnes per hectare of lime required to correct soil chemistry issues, but there was very little mention of the role of soil biology in nutrient availability. Soil science has moved along so much in the last 25 years. So, why are these experts still talking about soil having physical and chemical attributes and pretty well ignoring the role of biology? I think I'll throw that one to you, Graham. And I'd also be interested to, if you can, just a little bit touch on how you've seen agronomy and the focus change over your, I think you said 3 decades working in this space, please.
Yeah, unfortunately, I'm getting old. 3 decades makes me feel even older. But yeah, thank you. And very good question, to be honest. And look, I think I kind of be pragmatic and like if we think about the data that's available today, I can see why researchers have focused more on those measurable properties, those chemical properties like pH and structure, because we have some really good science and measurable data around that. When I think about biology, we really are still learning, and I shared some insights today in the presentation around that. But we, as a system, we need a lot more work and research done into understanding the dynamics of once you start changing that diversity in your soil and you get, because you've got to understand when you're putting microbes in the soil, it is boosting, if you get the right microbes, you are boosting the beneficial microbes, but you can potentially have an imbalance where you might actually have some pathogenic microbes. So that's why I think it's really critical that people understand which products they're applying. So I think it's more about we need more advancements in the science around how to, using DNA sequencing and biological indicators, how we can increase and adopt those practices better. And then we'll get more people talking about it. In answer to your second question, I think in horticulture, we've definitely seen growth significantly faster than the other crop segments. And I think that's mainly because of the intensive nature of those systems, but and the challenges around market access and availability. So they've been quite driven to actually change their practices around using alternative products than more of your synthetic chemistries, for a better word. So, but we are starting to see more, and I think when I think about it, and for people that may not be on the call, I've actually managed large agronomic teams over 200 agronomists. I think the challenge from an agronomist is a lot of their time is spent caught up in other areas, so they don't generally focus on it as much. And we're seeing actual producers and farmers adopt these practices faster than the agronomy world. So it's a changing dynamic on how things are getting driven at that farm gate level.
That's great. Thank you. Just one quick one, Graham. Do these biostimulants work for vegetables, or do you have any trials or research that you are aware of?
Yeah, absolutely. So we do. So on our website, but happy to share with anyone, to you guys if you want to share them. But we've got really good research in all crops, including horticulture, tree crops, vegetables. Yeah, no problems at all.
Harry, this is a bit of a trickier one. Do you have evidence to support the zero losses of dissolved urea nitrogen from volatilization, denitrification, or leaching?
Yeah, it's a good question. The short answer is no, I can't hand you a report paper on it. The critical thing that we use to measure it is what the yield is coming off at the end of the season. And when time and time again you're putting in these dissolved urea inputs and there's not been a yield penalty, the nitrogen's coming from somewhere. And as we match that to soil tests showing the nitrogen and the soil carbon is remaining the same or increasing, then we know that it's having an efficient uptake process. So it is absolutely something that we are working on. And also the GRDC, they're heavily looking at some of those interactions with nitrogen flows in the soil profile. So stay tuned on that front.
Great. And this is probably to both of you. How do your treatments compare to legumes being included in rotations? I'm guessing I'll let you answer.
I'm happy to go first, Harry, if you're happy. So
Sure.
I think you can't beat a legume rotation in the system. It's directly as a plant going to produce nitrogen and make nitrogen available to the soil. So that's a really good natural way of bringing nitrogen into the system. What I do think is it's and I keep referring to a systems approach. I think it's a part of a system. So we do still rely on fertilizers as well as building out natural biology and soil ecosystems, whether that be fungi or bacteria and other things like composting and I've just gone blank on the other one I was about to say, but that's okay. Yeah. So.
Yep, I would only support that, Paige. The programs that we typically help people transition to are only successful when you are managing the system with a legume in it. And if you don't have a legume in it, then you're going to struggle to go to a full dissolved urea application foliar nitrogen course. Absolutely essential to have legumes in the system.
That's great. This is sorry, I've just lost the word. What research is being undertaken to assist the free-living nitrogen-fixing microbes, and is there any plant breeding for varieties that are better for utilising free-living nitrogen fixers?
Yes, there is. So I don't have it in front of me, but if people are genuinely interested, I'll find the link and send it through. But it was actually quite exciting. I was at a conference only last week, and there is some wheat varieties that are actually supporting the growth of bacteria and microbes in the soil that are enhancing nutrient uptake, especially nitrogen uptake. So that's quite exciting. Outside your general legumes that we're all familiar with, it's great to see that we've now got cereal varieties coming through, and researchers have really focused on how they can using gene sequencing and changing. They are actually producing now varieties that can actually do that and help with the nitrogen use efficiency.
Thank you. That's brilliant. And on that note, I think we'll round out our questions there, and wanted to say a huge big thank you to Graham and Harry for coming along today. Obviously, as always, and as Graham and Harry said, do your own research and make sure you speak with your agronomist or whoever you use when making these decisions. But we just wanted to shed some light on some, sort of innovative and different ways to utilize urea, as well as some other biological options as well. And something that came up, several times in the questions and in your both of your presentations, is that need for greater research. And uh, if you are available and would like to hang around after, in a minute, we're going to have a bit of a chat on what Farmers for Climate Action is doing on the funding cuts to CSIRO, with one of our sort of premier research organisations, and all of the work as well that we're trying to do on the gas tax as well, which is a very hot topic at the moment. But yes, I'll give you all a virtual round of applause and appreciate you so much, Graham and Harry, for coming along. Thank you.
Thank you very much.
Thank you for having us.
Brilliant. All right. Thank you so much for those of you. We're going to attempt